Okay, guys, we have a recording started. If somehow the recording doesn't work, I'll put the PPT somewhere. I'll make a web link where everyone can download the PPT and they can um, read it anytime.
Yeah, that's good.
So we today's discussion is a very basic one. So we'll start with the cloud basics. What is cloud? Back in uh, 2002, the service, the cloud service was started by an engineer who wanted to keep the computing part on the internet, and they wanted to use the processing as a shared processing unit. So it was the requirement for by certain scientists who wanted to process their data through a cloud computing. So what they wanted to do was, each time we use the computer, there is some part of the computer that is not usable at that time. So those cycles which are not used, or those processing cycles which are not used by us at a certain time when the computer is on, they wanted to use those cycles for something else. This would have solved two different requirements. One was the requirement of testing the mechanical missiles, and the other one was the defensive system. They also wanted to test the communication through it. So these are the three things from where the cloud came into existence. Now, while they were creating this cloud thing, they came to know that they can um, deliver a service, deliver certain services through the connectivity. So it was known as global connectivity system at the first instance. After that, it was named as cloud, because now why the name cloud came into existence, because the global connectivity system was already taken by certain other certain other things, by certain other defensive systems communication. So they cannot name, they were not allowed to keep the same name. So that is why they found, they try to make it more logical name, and they came up with the name of cloud. So now cloud has different devices connected into it. It's same. There is an IP network, there is a SAN network, there is iSCSI network, and those three, when they are communicate, these three networks, when they are communicating with each other, that is known as cloud. Now this is what cloud is. So it's simply by if simply, if you see if you are able to see the PPT, the screen in front of you. So simply putting, cloud computing is the delivery of computing services, server, storage, database, networking, software, analytics, and more over the internet. Now we differentiate cloud into two different
No,
areas. One is private cloud, one is public cloud. If you guys have any question in between, just stop me there and ask.
because I'm not able to see any PPT, or it's just a desktop only which I'm able to see.
Let me share. I have shared this. Anyone
Yeah,
able
the
to?
same here. I
Okay.
only able to see the desktop.
Mm, okay, give me a minute. What is this? Guys, when you no, screen is shared. It says no, screen is shared. You should be able to see the PPT.
Can you move your cursor on the screen?
Yeah, I'm moving it.
No.
Okay, so
So
that
we got
means
stuck or some.
they stuck somewhere. Okay, just give me 1 minute. Let me stop sharing and share it again. Now, see if now see if my cursor is moving or still it is stuck.
Still stuck.
So let me do one thing. Let me put this PPT in the chat, and from there just download it. I don't know why I've used it many times. I have never gone through with this.
Sometimes I'm getting a message like the presenter's link is down and it can be established one more time. It might be an issue with your internet or something, or it's slow or something. Audio wise it's okay, but yeah.
Let me try a different connection. I have two of them working at my side.
Yeah, we can able to see now.
Yeah, PPT is visible, right?
Yeah.
Yes, yes.
Okay. Maybe that connection was slow.
Hmm.
So, this is what I have discussed till now. What is cloud and where it came from. Now, the cloud is not a hardware or any kind of um, is still not able to say my voice. It is not any device or a particular project that is given that can be sold to the customer. This is kind of service that you can provide. So the service is divided into two parts. One is the private cloud, one is the public cloud. Now, the private and public cloud have the basic integration is same. You will create virtual machines, you will integrate virtual machines, you will use compute, you will use storage, all types of storage, you will use HTTP protocol, you will use all the connections, physical connections, virtual connections, everything would be there, hypervisors would be there. But it is all only the accessibility that is differentiating between them. So private cloud is the cloud that is for a private company, that is used in internally by the company. It is not shared to the public, uh, to all the public. Whereas public cloud, basic integration is same, infrastructure is same, everything is same, but it is open to public. They can access it. Now, public cloud are created by the people, by the company, or a group of people who want to provide the cloud services to be used by the end user or end company. You're getting my point?
Yeah.
Hybrid is a mixture of private and public cloud. So you will keep private and public cloud as two different entities, but at the same time they are communicating with each other. This is one of the case for hybrid cloud. Yeah. Everyone understood it? So three things: private cloud, public cloud, and hybrid.
Okay.
Of cloud ownership. On depending on the private and public and hybrid, we have to differentiate the ownership. Who will do what customer will do, what I will do. So as a cloud owner, so as a say, if a company has a private cloud, it is customer's responsibility to manage the infrastructure. Infrastructure means the connections, the physical hardware, whatever it is, they have to manage the total infrastructure of private cloud. Security will be customized as per the customer requirement, because because all the data and the storage, all the connections are privately owned by that company. So they will tell us what kind of security they require, and they will also tell us what firewalls they will use. So we, depending on customer requirement, we will create this cloud. Policies and logs all are accessible to the company who has requested for the private cloud, and application data will remain behind the firewall. So that is why I was saying, the data will not, the data, all the application will not be available to the public. That will be internally used by the company. So this is this when this all points as an ownership, customer accepts it, that is the private cloud. Public cloud, the it is the provider's responsibility for infrastructure. Like we have AWS, Azure. So it is the responsibility of the provider to manage the infrastructure, whatever it is, hard drive failure, everything, connection failure, they have to manage it. Security control is as per the requirements of the provider. Now, if customer is working for, working with a particular firewall, and Azure and Microsoft don't want to put it, they can ask the customer to change their requirements. They will not provide the customized requirement as per the customer. Third is no visibility to daily operations. Now, daily operations in private cloud, because the storage and the connections and the firewall devices all are owned by the private organization, or or a group of people who have requested for the cloud, they have all the accessibility to logs and policies. Now, in public cloud, because the storage devices and other hardware is already is gonna be in a shared situation, so they will not provide you the logs and the policies. Now, you may have access to your system logs and your security policies, but that you have created in a public cloud. But on the other hand, the complete logs for the storage devices, firewalls, other things, they will not provide you. Difficulty to access the logs, because it is shared environment, they will not give you the access, or the credentials, or the authority to access the logs, complete logs and policies. Application and data are publicly exposed. So in that case, like Azure, AWS, Google, the application is available to the public, so they can use whatever services they require, and they will pay on hourly basis. And this is how we differentiate between private cloud and public cloud. Hybrid is something more related to public one. In hybrid, what will happen, say I want to create a hybrid cloud. What I will do is, there would be there will be a private cloud that is created for my internal employees to manage the services that are related to public cloud, and there will be a public cloud. There are certain things that will be exposed to public, that will be part of public cloud, and in between, those two services are interconnected with each other, and authority is still with the private cloud to provide the access to the things they want, the customer wants to access. So again, the authority is in between, is there in the private cloud. Like say I want to give an access to an accounting software that is created by my company. What I'll do is I'll create a VM. I'll install a application, and I will expose that application through a public IP to the outer world. Now, when they want to, they can manage their accounting to their software, but they cannot change the ports and other settings of the software, because that is the part of private, my private thing. So my private communication they cannot disturb. They can just use the application as a service. So this comes under application as a service. Now, cloud properties. What are the properties of cloud? Why we should use it, or what is an importance? What ease it gives us to, and why we are getting stretched towards cloud? It's dynamic. Dynamic means you want to create a VM. Earlier, what was happening? You go to a VM team, tell them that you need a VM, you provide the requirements, they will respond in the evening that we have our storage is full, and we don't have we don't have a compute capacity to create the VM, and that will linger on for another week or so. Here you provide a requirement. Your requirement have to be fulfilled in a particular time. So you provide a requirement, you get the things there and there. So on demand provisioning, you demand it, you'll get it. Multi-tenant, it is always shared, irrespective of private and public cloud. Even your private users are sharing the same hardware. So tenants, it is one to many sharing. One, in terms of the storage device, there is one VMware, and there are number of VMs, and those number of VMs can be used by number of users. On the other hand, number of users increases, the hardware remains the same. So it is used on the shared basis. Maybe you have a different departments in a company, and still they are using the same private cloud to access everything. So there could be multi-tenant users who are using, maybe different companies can use the same hardware. That will become a public cloud. So it depends how you want to manage it. Self-service. In self-service, what happens is you require a thing. You don't need to go to any person or talk with any person. You just need to run a command, and you will get that service online by there and then. So the time to access the things, or time to activate a particular service, or time to activate requires a infrastructure. He is working in an infrastructure as a service environment, and he requires a database. Now he wants an application as a service. He can activate there and then. So database as a service is also a part of cloud now. So he can use database as a service now. So it depends what service you require. You get pay for it. Pay as you go. We all know that it is pay hourly. It is pay as we go. As we use the service, it is all expense, and it depends on how much we have used, and how many how much compute we have activated to use it, depending on the prices which are fixed by the provider. Elasticity and scale out. Who knows what is scale up and scale out? Anybody who knows what is scale up and scale out? I think you guys are speaking on mute. Okay. Scale up is scale up means you want increase the capacity of a store. Scale out means you want to increase the processing capacity of you can increase the processing capacity of data. You can increase the storage capacity of data. So these are two things: scale up and scale out. Resources can be on premises or remote, which is ease of management. Now, rapid, as I already said, it is the deployment is too fast. It is easily managed because you have a single console to manage everything. So the lesser people are required, and they can manage more hardware at a single point, from a single point of accessibility. Automation and reusability, we have automated most of the things. Like if you require, say, requirement, say there is a server that is getting capacity from a storage unit. Now that capacity has already been consumed by the data, and more capacity is required. Automated, the server will put the request to the storage itself, and storage will provide the required capacity. It is automated, or everything is automated. You can automate everything through console you have. Reusability, once you have created a VM, it is not integrated with a particular service. You at VM for a different service as well. So yeah, like you are working in infrastructure as a service environment, and you require a database, you can install your own VM and put a database there, and say at the same time, same VM can have your IIS. So your VMs can be used for different things at the same time. And say you had a database and you don't require that VM for database, and you uninstall it and you put something else. Everything is, you can use it. It is available for you. Not to delete anything. You just need to put whatever you require, and you configure it as per your requirement. Now, the delivery models. There are three. They are known as software as a service, platform as a service, infrastructure as a service. Now, software. These are, if you see the picture, these are the building blocks of each delivery model, and that is how it is created. Your compute, storage, and network is a part of runtime, middleware, and OS. Say if you are using a hypervisor, there is an OS. On top of OS, there is a middleware that will integrate between your runtime and OS environment. Say you are creating a VM, your hypervisor is the middleware that is communicating with the OS and runtime, and what is the extension of VM, that file. My mind, just from my mind. That is the communicator between the hypervisor and the OS. So we have same way we have a platform as a service and IIS. So this is how these three models, delivery models, are used in cloud for the delivery. Now, why we require these delivery models? All the customers don't have the same requirement. Sometimes they have a requirement for infrastructure. They want to put their infrastructure to the cloud. Sometimes they just want a platform as a service. Sometimes they want a software as a service. I have differentiated between them like this. Only database is required. It will becomes as a platform as a service. Only they want to put their storage and all the servers on the cloud, that becomes infrastructure as a service. And they want to share their application, like there is an application called what we call, I have an example here. Yeah, Salesforce.com. The sales for sales project, most of the companies are using Salesforce.com. Lotus Live is an IBM email system that can be used, that they have put on the cloud, and they have given access to their employees and out of the world to access their mails. So these are the ways this is how they pay. So application, like your application is up for 20 hours a day, and it is used by people, and you will pay for those 20 hours, and a type of compute storage and network that has been used and middleware that has been used. So depending on the usability, they will provide you the service, and you will pay for, depending on the delivery model, you will pay for that service. Forming a cloud. Now most of the companies already have an on-premises infrastructure. So what happens is, there are steps that needs to be taken before we jump to the cloud. The virtualization has to be made, server automation has to be made. There should be standardized rules to manage those, to manage the storage and the servers that are virtualized, the capacity requirement and the processing requirement, and then there is a self-service. So these steps has to be performed each as written, and then you will finally, when these all things will be there, is that will become a cloud. So cloud is equal to virtualization plus server automation plus standardization plus self-service. These four things make cloud. Phases of cloud preparation. Now this is in the earlier slide. In this slide, we just found out what we need to do if there is already a on-premises infrastructure that the company is using, and they want to put everything into the cloud. They have to virtualize the thing. They have to the servers needs to be automated, and then the standardized instructions has to be made, and then there is a way to self-service. So that is that these three things are required. These four things are required to create a cloud. Now, for each those things, how the cloud, what are the phases of cloud? For virtualization, you need a hypervisor, VMs, CPU, and memory. I have written VMs. VMs is not particularly a part of the phases, but I have written here because you have to count the VMs, number of VMs, and their requirement depend, and you have to see if you have the CPU and memory requirements as per the requirement of the VM. So you have to match these three things before you virtualize any server. Hypervisor is a way to manage these VMs and CPUs, that it will help you as a communicator between OS and the VMs files. Storage, number two. Virtual switches. Now when you create a cloud, you are working on a virtualized, everything will be virtualized. So you need to know what is virtual switch, what are virtual NICs, VLANs, VPNs. We will discuss in detail in the coming weeks. I'm just providing the requirement here, what we need to know, and what we will do, what we will use while creating the cloud. Number three is storage. We use directly attached storage. We use network as a storage. So all SANs and iSCSI devices and DAS and NAS, everything will come between storage. We all know this part is actually it was growing as a service. Now the cloud has come, so these all are integrated into one thing that is known as compute. We need to have web services, because all these three categories has to be attached to the web to make a cloud. So for web services, we will either use SOAP, XML, or REST API. Now for OpenStack, we have OpenStack installation. We need a Linux operating system. The supported ones are Linux, Ubuntu, and CentOS. Sorry. CentOS. Now we have 7 to 8 layers that are part of that makes an OpenStack. Keystone is the OpenStack authentication system. when you log into the GUI of a cloud, if you see as if you already have seen Azure or some other cloud service log, there is a login you need to create. This is an authentication system for OpenStack that is known as Keystone. Nova is the compute service where your all storage will be there. So everything related to compute will be in Nova. That in OpenStack we call it Nova. Sender is the OpenStack block service. Glance is the OpenStack image service. Now, OpenStack block service is the block storage. Image service is the image repository. So I have written in the brackets also for the ease. Newton is the OpenStack Newton service. It is a part of networking. All your virtual switches, virtual NICs, or everything that is related to a network that will come under Neutron. Horizon is the OpenStack dashboard. You have a GUI. It is an OpenStack GUI, which is known as Horizon. Heat is the OpenStack orchestration to orchestration service. All your hypervisors, all as for VMware, you have a hypervisor for it. Heat is a hypervisor for OpenStack. Ceilometer is the billing software that you will use, that will be integrated for billing purposes. Trove is the database as a service. We have all your databases can be a part of Trove. If you are, look at these layers as you are a cloud provider, so only then you will understand what it is. Swift is an object storage. Object storage is the storage where it looks all the things as an object. For example, there is a NFS file, it will look at it as an object. For a Word document, it is object for it. So everything is object for it. It doesn't differentiate between filers and other things. So that is object storage. Now I want to discuss who want to take what in for this. I mean, who for further discussing this topic, maybe tomorrow or from the next week, I want to keep the names with me who want to keep what, so that we know who is gonna distribute what, who is gonna discuss what topic. I had someone who wanted to keep Thunder and Nova and Thunder, I believe. Let me look into it. There was one person who asked me to give those topics to them. Hmm. Hmm. So if you guys have any question, let me know. I'll answer. I'll answer the questions you have. Yeah, Pranay Sagar wanted to take Cinder and Swift. He's not available today. Yeah, any one of you want to take any topic from this PPT? Yes, no, maybe. Am I audible?
Yes, you are.
Yeah. How many of you have experience with OpenStack? Okay.
No, very new.
You guys are new, right? Okay. What I'll do is I'll discuss these all topics one by one every week, and in the meanwhile I'll try to create labs on those, and we'll discuss it. No worries. I'll keep all the topics, and I'll do it one by one every day. What I'll do is I'll update this particular PPT every time, and I'll put it somewhere. I'll give you the link to that place where I'm putting it, so that you guys can look into it later where you want to revise or see something into it. So that way, a single PPT will have everything into it, and all the lab work also, everything will be in the same PPT with all the topics that we'll discuss um, in the coming weeks or so. Coming week, I'll start with the keystone, the OpenStack authentication, and I'll and I'll try to um, um, if this would be a small topic, then I'll cover or what I'll do is I'll discuss all the layers, the basics of the layers, and we can then I can distribute the work between you guys, and you guys can help me in discussing this. I'll let you guys when you are discussing. I'll update if I have anything new, and that way I'll keep it this I want to keep this these sessions interactive between us, so that we all come to know if there is anything new, or if we are lacking somewhere to discuss these things.
Okay, is it necessary um, I mean, to master in Linux to
Yeah,
understand OpenStack?
I had the same questions a week or a week ago. I asked the same question when I started with cloud, and you don't need to master Linux. You should know the basic and some of the advanced topics like troubleshooting and other things. But I don't think we need to master Linux for this. Basic to advanced information at certain point, at certain topics you need to know advanced information, like for the uh, integration of Nix or FC uh, protocol, how to do mapping in Linux. You should know that. What are the different errors that come while creating uh, uh, connection, IP connection in Linux, that you should know, and what are how the Linux operating system works. So the basic commands like look into the NIC and NIC number, the IP addresses, the FC IDs, and the basic information you should know. While you would be working on once it's like once the OpenStack is installed on the Linux server, the CLI and other things are different for OpenStack. So basic information should be enough. And if there is anything that is required to be that is required that requires advanced knowledge on Linux, we'll discuss, and I'll keep giving you notes and whatever I have at my side. That way we can help each other to progress on OpenStack.
Okay. And what about the cloud security? Is there any topic in OpenStack? I mean,
Cloud security is a part of every cloud service. OpenStack also comes under it, but we use firewalls to do it. So we once the VMs are created and other like your storage is connected and your all these layers are working, you will create a firewall and you will create an access restrictions and other things for this for the security purposes. It's same.
so
It's
those
same
topics all
as
comes under the Neutron, I think.
that Neutron is your networking part where you can add additional firewall services to get access to provide an access to your OpenStack GUI, which is uh, like which is horizontal. So if you say if you want to keep do you know there are two-step authentication methods that we can use. You can use two-step authentication method. One, when your Horizon Vista will come online and they require an authentication. Another one for the firewall issuance authentication. So you can use two that way. It all depends how you configure it.
Okay. Hmm.
Anybody have any other question on this? Okay, you can keep note of my contact numbers, and here I'll put this PPT somewhere as well. If you want to keep it handy now, you guys can keep it, and you can contact me if you get confused with anything. Um, my recommended way of communication would be through email, because sometimes I'm not available on my mobile because of business requirements. So it would be good if you send the mail through mail at the given email address, and I'll respond to those. And I will create OpenStack um, channel for on the name of my there. So I on under the video, so everyone can put question and I'll be
Voice breakage, man. Getting voice breakage. Hello? Hello?
Sanjay, I can hear you, but I cannot hear Mandeep.
Yeah, now I can. What about the practicals? I mean, if it is in on premises like that, I mean, if it is a cloud, we can use like Azure or AWS, we can go through online. If somebody doesn't have any infrastructure to do all those things, so for those people, how come? Hello?
yeah. Sorry guys, I got disconnected again from the call. What I was saying, I'll open a channel on YouTube, and I'll create another um, um, access to the PPTs on the internet. I'll give you the links for both the sites, and you guys can ask me question on email, and you can put questions through on the videos as comment, and I'll keep you posted for the links. I think that would be a good way to go.
Okay, that's good.
Okay, guys. Today we just discussed the basics and the topics. Um, there will be no session for tomorrow. Every Saturday, come as we progress week wise. We'll start two sessions on the weekends, Saturday and Sunday both. But right now, I would like to keep one session per week. So let's start. Let's progress. One session per week. Let's read more things and get on to OpenStack. And once we are on to the implementation part, that time I would like to keep two sessions per week, Saturday and Sunday. That is my way to go. If you have any suggestions, let's discuss it now and let's finish the call after that.
I think session timings will you can change. Why? Because the people having their issues, or I'm not sure. So you can change to 8 o'clock. It should be good for all.
Yeah, sure. For next, what I'll do is if I change the software by Wednesday or Thursday, I'll give the link. We'll we'll test it on Friday maybe before the session, and on the session be able to join at the same time. I'll change it to 8 o'clock.
And send me the link of those PPTs or something else,
Yeah,
so we can.
as soon as I upload those to internet somewhere, let me think what I can do, where I can put it, and I'll provide you the link as well. Yeah,
Yeah, sounds good.
yeah. Okay, guys. Thank you for coming up for the meeting. Thank you for bearing me for on the theoretical part. I know it's little today. It was little basic. Some of you would have known to it, or some may have got the new things from it. Um, I wanted to touch the starting phase of the cloud. That's it. Nothing from my side. I found it interesting to discuss, and let's move it on the coming Saturday, 8 o'clock with the time when we'll start the meet. I'll keep you posted with the links. Thank you, guys.
Thank you. Appreciate your help,
Thanks,
man,
man.
guys. Thank you. Bye bye.
Bye bye.